Welcome, my name is Per Jung. Today we have another episode of questions and answers, and we will answer some of your questions. We have different methods for trimming. The simplest form of trim, commonly used on a general aviation airplane, is trim tabs, and they are located on the elevator. They can be either electric, mechanic or hydraulic, and they can be controlled from the cockpit. You will also have a trim wheel or a switch on your yoke. The reason why we trim is that we want to cancel out any control forces, and we trim for a certain airspeed and thrust setting. If your plane is equipped with trim tabs, they will move in the opposite direction. If you want to trim nose up, the trim tab will move down and the elevator will move up. If you want to trim nose down, the tab moves up and elevator moves down. The negative side is that you will have less control authority, more drag, and also a less CG range. If your airplane is equipped with a stabilizer or an all-moving tail, the entire surface will move and your angle of incidence will change. This is good for several reasons. For example, we will have a larger CG range, we will have less drag, and you will always have the same control authority. It is used on modern large jet airplanes. AIRAC stands for Aeronautical Information, Regulation and Control, and it contains information about nav aids, terminal arrivals and departures, runways, and so on. This information is updated in the navigational database of the aircraft and is read-only, meaning that the pilot cannot make any changes. 2 AIRAC cycles are loaded, the current and the recent version. An update is mandatory every 28 days. The ground crew loads this new information into the navigation computer, and then the pilot can activate it via the CDU. Everything in civil aviation should always be redundant to minimize the risk of a major technical malfunction. From structural load-bearing redundancy, emergency oxygen supply, to multiple hydraulic systems, we are striving to have 2 or more components of everything, even pilots. If you are flying in a large airliner, you will probably have 2 or even 3 autopilots. They are both used simultaneously in an autoland and are required for any automatic precision approach. The heading bug is connected to your flight management computer and IRS. Let's say that you'll lose your area navigation because you're out of range of any VORs and DMEs. Your flight management computer will use dead reckoning, IRS and GPS for position and navigation acquisition. The FMC has its own magnetic variation database and can calculate your magnetic heading from the IRS through north sensing. If you lose your IRSs, you can revert to AT mode and acquire a heading and attitude on your primary flight display, and you will still be able to use your heading bug, but the autopilot will not work. The IRS knows by itself where true north is and can sense the accelerations and movements of your plane, so you will always keep attitude and heading information. So the answer to your question, yes, if IRS is working. Decision height is used in ILS precision approaches, while MDA, or minimum descent altitude, is used in non-precision. When we are using decision height, we have to decide about go-around or landing at the height. But if we have minimum descent altitude, we have to decide before. When we fly category 2 and 3, we will use the radio altimeter for decision height, but when we're flying category 1, we will use the barometric. Vx is the best angle of climb speed, and Vy is the best rate of climb speed. If we climb with Vx, we will cover less ground distance, but climb with a slower speed. If we climb with Vy, we will have a better rate of climb and a higher airspeed. The best climb speed, Vy, for a jet is minimum drag speed, and for a propeller it is 1.1 multiplied by the stall speed. It's also important to know that you will have a better rate of climb in a clean configuration. Flaps is good to reduce your takeoff distance, but will reduce your vertical speed. And if you want to avoid obstacles, the best speed is best angle of climb speed. So I hope you found this video informative, and see you next time.